Download this code from codegive.com, link in the description below. ReadableStreamStreamer breaks UTF8 characters, causes, fixes, and best practices. The ReadableStreamStreamer in libraries like langchain or similar streaming-based frameworks is a powerful tool for delivering large text responses incrementally, often used in LLM applications. However, it can sometimes exhibit issues with UTF8 character encoding, resulting in broken or garbled text when dealing with non-ASCII characters like emojis, accents, or characters from other languages, Chinese, Japanese, etc. This comprehensive tutorial delves into the causes of this problem, provides practical solutions, and outlines best practices to ensure your streaming applications handle UTF8 encoding gracefully. Understanding the root causes. The issue with ReadableStreamStreamer and broken UTF8 characters often stems from one or more of the following factors. 1. Incorrect encoding at the source ***. LLM output *** the LLM, large language model, generating the text might be configured with a different encoding or might be producing text that isn't strictly valid UTF8. This is less common but crucial to consider. Data source *** if the LLM response is based on data retrieved from a database, file, or external API, the data source itself might be using a different encoding, example Latin 1, GBK. 2. Incorrect handling during streaming ***. Buffer boundaries ***. The most common problem is that the ReadableStreamStreamer might split a UTF8 multi-byte character across buffer boundaries. UTF8 characters can consist of 1 to 4 bytes. If the streamer splits the byte sequence in the middle, the incomplete character will be misinterpreted, resulting in a garbled output. Encoding/decoding mismatch *** The stream of bytes coming from the LLM needs to be correctly interpreted, decoded, into a string using UTF8 encoding. If there's a mismatch between the encoding used to produce the bytes and the encoding used to decode them, you'll see corruption. 3. Consumer-side problems ***. Terminal/browser encoding *** The terminal or web browser displaying the stream text might be configured to use a different encoding. This isn't directly related to the ReadableStreamStreamer itself but can cause rendering issues. Incorrect decoding on the client *** If you're receiving the stream on a client, example a web browser, you need to ensure that the client-side code correctly decodes the incoming byte stream as UTF8. Illustrative example, Python. Let's demonstrate a scenario where the ReadableStreamStreamer can cause problems and then explore solutions. In this example, simple streamer attempts to stream the text. Without proper handling, characters may be broken if the LLM sends back data in chunks that split multi-byte UTF8 characters. This is a very basic example, and depending on the nature of the OpenAI wrapper and how it feeds data to the streamer, the problem may not be immediately apparent. But it serves as a demonstration platform for the solutions below. Solutions and mitigation strategies. Here's a breakdown of how to address the UTF8 encoding problems, addressing each potential cause. 1. Ensuring correct encoding at the source ***. Verify LLM configuration ***. Consult the documentation for your specific LLM library, example OpenAI, Cohere, Hugging Face Transformers, to confirm that it's configured to output UTF8 encoded text. Many LLM libraries default to UTF8. Database connections ***. If your LLM uses data from a database, ensure your database connection is configured for UTF8. In Python, for example, you might use file handling * when reading text from files, explicitly specify the encoding. API responses * when consuming data from external APIs, check the content type header in the HTTP response. It should indicate charset equals UTF8. If it's missing or incorrect, try to explicitly decode the response body as UTF8. 2. Handling encoding correctly during streaming, the core solution. Buffered accumulation. The key to solving the buffer boundary issue is to accumulate the incoming bytes until you have a complete UTF-8 character before emitting the text. You can implement a custom streamer that does this. Here's a refined simple streamer example demonstrating this. Explanation of the UTF-8 safe streamer buffer this attribute accumulates the incoming tokens, which are strings. On llm new token it appends the new token to the buffer. It attempts to encode the buffer using UTF-8 and then decode it back. This crucial step checks if the buffer contains a complete, valid UTF-8 character or sequence. If the encoding/decoding succeeds, no Unicode decode error, it means the buffer holds a complete character. The buffer's contents are appended to self.txt, and the buffer is reset. If a Unicode decode error occurs, it indicates that the buffer contains an incomplete UTF-8 character. The code pass ES, meaning it waits for the next token to be added to the buffer to complete the character. On llm end after the LLM run finishes, there might be a partial character left in the buffer. This method flushes the remaining buffer contents to ensure that no data is lost. Using codecs, alternative. The codecs module provides more sophisticated encoding/decoding tools. You could use its incremental encoder/decoder to handle the streaming. In this version, codecs.getIncrementalDecoder, UTF-8, creates an incremental decoder that handles UTF-8 decoding piece by piece. The decode method adds the new token and returns the decoded, complete, string. The final equals true argument in on_llm_end ensures that any remaining buffered data is decoded at the end of the stream. 3. Addressing consumer-side problems Terminal configuration in your terminal, make sure the character encoding is set to UTF-8. On Linux/Mac OS, you can often set this using the lang environment variable, export lang equals n_us.utf8. In Windows, you might need to adjust the console properties. Web browser configuration Web browsers generally default to UTF-8. However, if you're encountering issues, check the content type header of your HTML page. It should include charset equals UTF-8. Client-side JavaScript when receiving the stream in a web browser, use the text decoder API to decode the incoming byte stream. The uint8 array is a typed array that represents a sequence of bytes, which is how the data typically arrives over a network stream. The text decoder converts this to a JavaScript string. Best practices for robust UTF-8 handling in streaming applications 1. Explicitly specify encodings always be explicit about encoding. Don't rely on defaults that might vary across systems. Use the encoding equals UTF-8 parameter when reading/writing files, specify charset equals UTF-8 in HTTP headers, and configure your database connections appropriately. 2. Test thoroughly with diverse characters Test your application with a wide range of UTF-8 characters, including accented characters, AEIOU 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 AEIOU. Emojis, party popper thumbs up smiling face with smiling eyes. Characters from different languages, Chinese, Japanese, Korean. Special symbols, copyright registered, etc. 3. Centralized encoding/decoding logic ** encapsulate the encoding/decoding logic in reusable functions or classes to avoid duplication and ensure consistency. 4. Logging and error handling * include robust error handling to catch Unicode decode error exceptions and log them for debugging. This will help you identify encoding-related issues early on. 5. Monitor system locales * be aware of the system's locale settings, especially if your application interacts with external processes or libraries that might be sensitive to the locale. 6. Validate UTF8 data * consider adding validation steps to ensure that the data is indeed valid UTF8 before processing it. You can use regular expressions or libraries like FTFY, fixes text for you, to detect and correct common encoding errors. 7. Upgrade libraries regularly * keep your LLM libraries, streaming frameworks, and other dependencies up to date. Newer versions often include bug fixes and improvements related to encoding handling. Complete example with client-side decoding, conceptual. This is a simplified conceptual example to illustrate client-side decoding. It requires both server-side streaming, using the UTF8 safe streamer or codex UTF8 streamer from above, and client-side JavaScript. Server-side, Python, using Flask for simplicity. Client-side, JavaScript. Important considerations for the client-side * server sent events, SSE. The server-side example uses SSE, text/event stream MIME type, which is a common and easy to use way to stream data from a server to a web browser. SSE automatically handles some of the streaming complexities. The client-side code listens for the message event and appends the received data to the output div. No explicit decoding is needed for the data portion if the event.data is a string, which Flask's yield will ensure. * Fetch API with streams. Alternative, if you don't want to use SSE, you can use the Fetch API with response.body.getReader. This gives you more control over the streaming process, but it requires you to handle the reading of the stream and decoding of the bytes manually. * Text decoder * The text decoder API is essential for decoding the incoming uint8 array, byte stream, into a JavaScript string. In summary *, UTF-8 encoding problems in streaming applications can be tricky, but by understanding the potential causes, source encoding, streamer buffer handling, consumer-side issues, and applying the solutions outlined in this tutorial, you can build robust applications that correctly handle UTF-8 characters and provide a seamless user experience. The key is to handle the stream of data incrementally, ensuring that you only decode complete UTF-8 characters at a time. Always be explicit about encodings, test thoroughly, and monitor for errors.